Number 3, we reverse the order of the bit. So when you reverse the order, 0, 0, 1, 0 become 0, 0, 1, 0. If you reverse the order, that means you go the other opposite direction, then it will become 1, 0, 1, 0, 0. And after you reverse the order, whatever you got here should give you the value of p, which is the power that you're supposed to raise over the variable w. So if p equal to 0, 1, 0, 0, what is that value? Well, again, this number 0 right there is corresponding to this term, 0 times 2 to the power 0, like I told you before. The next number 0, which is in red color, in the second position, that corresponding to 0 times 2 to the power 1. The next number, let's say number 1 in here, that corresponding to 1 times 2 to the power 2. And finally, the number 0 that I show in the green color will corresponding to this term. So in binary form, the value of p equal to 0, 1, 0, 0, and in the normal base 10, the value is equal to 4. So if you use, let's say, binary form, which means base 2, the value of p is equal to 0, 1, 0, 0. If you use the base 10, which is the most conventional way that we do every day, then the value of p is equal to 4. So that means corresponding to the index k equal to 8, the power p that you're supposed to raise will be equal to 4. Okay? So up to now, what it means is this. To summarize it, if you know, let's say, the value of the index k is equal to 8, the value index k equal to 8, how do we find out the value of the power p? Well, it boils down to, look at this here. If you know the value of k, that means you can use this formula to calculate the value of capital M. After you know the value capital M, let's say equal to 2 in this case, all we have to do is, can we represent that value M in terms of the binary form? If we can represent the value of M in the binary form, then you can see in the next step, number 3, we can figure out the value of P. So that is the main idea. Okay? So in the next few slides, I will explain to you a little bit more detailed computer implementation. Okay, so here, like I told you before, in order for you to find out the value of the power P, first step, you have to calculate the value of M based on this formula. Then, after you know the value of M based on that formula, we try to express that value of M in binary format. When you use that binary format, it means the number has to be represented by a bunch of either 0 or 1. And you have to use R bits. And this number R corresponding to n equal to 2 raised to the power R. So if n is equal to 16 data point, the power R should be equal to 4. So in that case, that means you have to use 4 bits in binary form to express the value of M. And that value of M, you can always calculate it based on the index k that you want to compute. So, like in this case, we have to express the value of M in binary form using 4 bits. So, let's say I will represent it in this way. A4, A3, A2, A1. So you see, we have to use 4 bits. That means you have to represent it by 4 binary number. A4, A3, A2, A1. And because it is a binary number, it means the value of A4 or A3 or the value A2 or A1, it must be either 0 or 1. So the way it works is, we know the value of M. How do we find out those bits A1, A2, A3, A4? All right. First, we say the value of M that we know, call it J1. Okay, as we show in equation 19. The next thing we do, we divide the value of M that we already know. You divide that value M by a factor of 2. According to the previous slide, because I told you the value of M, you copy into a variable called J1. So when you divide M by 2, it is the same thing like dividing J1 by 2. J1 divided by 2 is the same thing like M divided by 2. That J1 divided by 2, you give it a new name, you call it J2. Then after that, you multiply the truncated result by 2. Like for example, the truncated result is J2. J2 is a truncated result. You multiply that by 2, okay? And the product of J2, which is the truncated result, you times 2, you call it JJ2. Then after that, we compute the difference between the original number, which is M, compared to the new number JJ2 that we just compute. Let's see. So the difference, you can calculate it based on the original number, which is J1. Remember, J1 is the same thing as M. Remember that. And the difference between the original number J1, you subtract from JJ2. And what is JJ2? JJ2 is equal to the truncated number, like I told you before, times 2. You see? So JJ2 is equal to M over 2 times 2. Now, if the answer for this difference equal to 0, then that bit A1 should be equal to 0. Otherwise, if the difference is not 0, then that bit A1 should be equal to A1. So A1 equal to 1. So now you already figure out what is the value of the bit A1, either 0 or 1, depending on the value of the difference. The next thing we can do is the value of J1, which is originally set equal to the value M. Now the value of J1 is set to be equal to J2. So basically what it means is the value J1 is reduced by a factor of 2. Okay? Now you remember in the previous one we say the original value M is the same thing as J1. We copy that to J1, and that M will be expressed using 4-bit binary form. So J1 will be equal to M, and because you know the value of M already, therefore we can express this value M in terms of the binary form. Okay? Then the similar procedure, after you figure out A1, you can use the same procedure to obtain for the next bit, which is A2, and then after that you can calculate the next bit, which is A3 and A4, using the same procedure as the one that you calculate A1. So let me give you a numerical example to demonstrate.